For the video, today we're looking at question 33, search in a rotated array. The way we'll be approaching this problem is by using binary search, but we will be leveraging the fact about which part of the array is sorted and use that to understand where we want to actually search. It becomes easier once we start writing up the solution, so let's jump right in. The first thing we need to do is cover the test cases. So you would check if nums equals null, or if nums.length equals 0, you would just return -1. If not, we need to get the indices for the left and the right index. So int left would be 0, int right would be nums.length -1. Awesome. And then you have a while loop that says if int while left is less than or equal to right. Awesome. And in the end, if we still haven't found the element within the while loop, you would just return -1. Perfect. So once we're within the while loop, we need to get the mid element. So that would be left plus right minus left divided by 2. Awesome. And then you would check, hey, you know what? Does the element exist in the mid index? If yes, we would return that immediately. If not, we check which part of the array is actually sorted. So to do that, you would say, hey, if nums of start, if it is less than or equal to mid, we know that the left array is sorted. And we can leverage that to check if the element is right there. So how do we check that? If target element, if it is greater than or equal to nums.start, and if the target is less than mid, we know for sure that the element exists between these two indices. So you would assign right to be mid -1. Else, you would say, okay, the element doesn't exist, and then we have to move to the right side of the array, so you would just assign left to be mid +1. Awesome. So if this left side of the array is not sorted, we need to look on the right side. And then how do we do that? If we need to look on the right side of the array, we can check if the right side of the array is sorted and the element is between the mid and right, then we search to the right. And how do we do that? If target, if it is less than or equal to nums of right, and target is greater than nums.mid, we know for sure that the element exists in the right side of the array. So then you would say left equals mid +1. Else you would move to the right side, to the left side of the array. So you would assign right to be mid -1. So let's quickly, this is left, this is left. Okay, so let's double check this. So if the left side of the array is sorted and the array is greater than or equal to left but less than nums of mid, then you would want to look to the left side of the array. So you decrement right. If not, you look to the right side of the array. That's good. And then if the target element is less than or equal to the last element that we're looking at but greater than the mid, you would say left is equal to mid +1 and right is mid -1. Awesome. This looks all right. Let's compile this. First test case is okay. Output is -1. Expected is 4. All right. So where could we have gone wrong? So if nums of left is, oh right, nums of mid. Let's try that again. Let's run this. This looks okay. Awesome. So that's how you solve this problem. Let's talk about the space and time complexity of the entire solution. The time complexity of the entire solution is log n because we are using binary search to find out where our target element is. And then the space complexity is of 1 since we use constant space. Awesome. If you have any questions about the solution, please let me know in the comments below. Please don't forget to subscribe and like the video. I would really appreciate it, and it motivates me to keep making more videos. Thank you so much. I'll see you all in the next video. Peace.